Hi guys, in this video we will look at another important pattern of dynamic programming, which is the inclusion exclusion pattern, or sometimes people also call it as knapsack pattern because it is used in the 0-1 knapsack problem. Right? So let's try to understand what this pattern is. Actually this pattern is very simple, and if you know about it, just a second, let me open the whiteboard. Okay, so this is called the inclusion exclusion pattern. Okay, now the key idea or the key decision in this pattern is that you iterate over different elements and then you either decide to include that element or you decide to exclude that element. Okay, that is the key decision, right? That you need to make. Now, what you will do once you will try to include that element and try to compute the answer then, and once you will try to exclude that element and then compute the answer, right? And based on that only you will move forward, right? That is the key point. So let's understand it with the help of an example. So we have something called as a subset sum problem. Right, so let's understand what this problem is and then we will look at the solution. So the subset sum problem states that you are given an array okay, you are given an array like this, okay, and you need to decide. Let me change the test case. Okay, so let's keep this test case only. So let's say we have this test case, and what we need to do in this subset sum problem, we are given this test case array and we are also given a target value. So for example, let's say target value is 12, right? So you need to find out, you need to just print a simple yes or no, that is there a subset with the sum equal to target sum. So basically, is there a subset in this array which has a target sum equal to 12? Okay, so subset is basically you pick up any random elements from the array in any order, that is called a subset. So for example, answer here is yes, there is a subset which is 8 plus 4, right, which has a target sum of 12. Correct. Another subset which has a target sum of 12 can be 6 3 sorry 6 4 and then 2, right? Or another subset can be 6 3 and then 2 and 1, right? That can also be another uh, subset. So you need to just print yes or no. As long as you are able to find even one subset, you need to just print yes. How do we do that? Now if you think about it, the main point of confusion here is that which element is a part of the subset and which element is not a part of the subset, right? That is the main confusion, because once you start iterating over the array, how will you decide that this element should be in the subset or this element should not be in the subset, right? So we don't really have a way of doing that. So what we are going to do, with that decision in mind, we are going to take two decisions, right? First we will try to include that element and then we will try to exclude that element, and then we will try to see if that inclusion works or if that exclusion works, right? So for example, I am going to make a function f of I comma sum. Now this function is going to tell me, is there a subset from index I onwards with sum which has sum as sum, with sum as the sum argument that I'm passing, right? So is there a subset from index I onwards? Let me just move myself. Is there a subset from index I onwards with sum as the given sum that I am asking, right? So obviously we need to find f of 0 comma target, correct? Or we need to find f of 0 comma 12, because here we are talking about the full array, right? So from index 0 onwards, do we have a subset with the given sum as 12, right? That is the question that I'm asking. Now if we think about it, let's say we go to the 0th element, right? Now when we go to the 0th element, what happens here? Either we will decide to include this element in our subset or we will decide to exclude it. So let's try to see if we decide to exclude it. If we decide to exclude it, then we are saying that for this remaining part of the array, the red part, we need a sum of 12, right? So f of 0 comma 12 will be true if f of 1 comma 12 is true, right? Basically I am able to find the subset from this index 1 onwards, right? Or if let's say I decide to include 2, then from the remaining red part I only need a value of 10, f of 1 comma 10. As long as these are true, any of this is true, f of 0 comma 12 will also be true, correct? Remember, we don't have to print the exact subset, we have to just print the true false value, at yes or no value. So as long as f of 1 comma 12 or f of 1 comma 10 is true, f of 0 comma 12 will also be true, correct? Similarly, if we talk about f of 1 comma 12, let me write it here. If we try out f of 1 comma 12, when we are at index 1, we decide to either include 1 or we decide to exclude 1. So if we decide to exclude 1, then we will go to f of 2 comma 12. It means we are saying that f of 1 comma 12 will be true only if this part is able to form a 12, right? Or if I decide to include 1, then I need to form 11 in the remaining blank part, right? So similarly, if you will see, our index is going forward. Now from f of 2 comma 12, we will go to f of either 3 comma 12 or we will go to f of 3 comma 8, because second element is 4, right? So either we will decide to exclude it. If we decide to exclude it, then the picture remains the same, f of 3 comma 12, or it will become f of 3 comma 8. So eventually we will reach the last element. Okay, and when we are reaching the last element, if we decide to include that particular element and that element's value matches the subset, matches the sum value, we will return true. Okay, like for example, if I reach the last element, okay, the light green part, so I will say 0 1 2 3 4 5, I say f of 5 comma 6. Now obviously this value will be false, because in the light green part, which is index 5 onwards, I can definitely not form 6, right? So when you reach the last element, it will be true only if this value of the last element matches with the subset value. So if you ask me what is f of 5 comma 3, yes, it is true. Or if you ask me what is f of 5 comma 0, it is also true, because I can form the sum 3 by including 3, and I can form the sum 0 by excluding 3, right? So if any other number is there, then definitely that's a false. So that is the idea. That is why I'm saying it is inclusion, exclusion, right? You have a decision to either include that particular element or you decide to exclude that particular element, and this is the main pattern. That is it, right? So this is something that you need to keep in mind. Okay, so let's look at our implementation for this. Okay, so I am switching to my terminal now. I have written the code in Python, but it's like you can just copy it in any language that you want. Okay? Now if you look at it, right, let me copy the array second that I have written 214683. Okay, now let's say my target value is what, 12, and I'm going to return this part. Okay, f of 0 comma target. Okay, so what I'm going to do here, see, my I value is the index on which I am, and m value is the basically m value is the sum that I need to form, the remaining sum that I need to form, right? Now if m is equal to 0, then definitely I can return true, because I can just exclude any element and I can just simply short circuit and return true. Otherwise, if I is equal to n minus 1, if I am at the last element, then if last element's value is equal to remaining sum's value, which is m, remaining sum is m, then I am going to return true. Like I told you that if you are at the last position and your remaining sum, the target that you achieve, matches with the element's value, you will return true. Otherwise, I will return false directly, because 0 case is covered on top. Else, if that is not the case, then first we will have the inclusion case. So in inclusion case, what happens? We can decide to include only if, let's say, this particular element is less than equal to m, and we are able to form the remaining target I plus 1 space m minus a of I, because I have already included a of I in the sum, so the remaining sum would be m minus a of I, the sum that I need to form till here minus the a of I value, the current element's value. Otherwise, excluding, if we exclude, then the remaining sum for I plus 1 also remains the same. So we will return either include or exclude. Right? If any of that is true, we will return true. Right? So let's test it out. So answer it is giving is true, because yes, 12 is, I can form 12, right, using this array. If I try some other value, let's say 34, it is returning false because I cannot form 34, right, using any subset. If I form another value, let's say 15, answer is true because 15 is formable, right, 8 plus 4 plus 3. So our code is working correctly. Of course, it is inefficient because we have not implemented DP, we have just implemented recursion. We have to still implement DP here. So what I'm going to do, I'm going to create a, I have to implement memoization here. So I'm going to create a DP hash table, which is initially empty. And after that, what I'm going to do in the else part, if this particular key I comma m in DP, sorry, not in DP, then I'm going to calculate it. Because if this key is not in DP only, then I need to calculate it, right? Otherwise, if it is already present, then I don't need to calculate it, right? So I will, if it is not in DP, I will calculate it and store it in my DP table. And at the end, I will return DP of I comma. Okay, so this will also work properly. So now the code becomes optimized after memoization. So I hope this is clear. Okay. So please remember this pattern. This is very common pattern, and probably we'll look at another example for this in one of the next ones. Thank you.